Yeah, greetings friends. On this day we are going to study in this video about algorithms. These are the four things we are going to study today: definition of the algorithm, properties of algorithm, algorithm development approaches, and flowchart development. Let us see the first one, the definition of an algorithm. An algorithm is a step-by-step method of solving a problem. If a problem is given, we are going to divide that problem into various steps, from the starting step till ending step. It is commonly used for data processing. The algorithm is used for data processing. It performs calculations and other computer related mathematical operations. Let us see the properties of the algorithm. First one is finiteness. An algorithm must always terminate after a finite number of steps. It must not be infinite. As per this property, if an algorithm has infinite number of steps, then it is not called as a algorithm. It must have certain limit or certain set of steps. The next one is definiteness. Each step of an algorithm must be precisely defined. We need to define each and every step in the algorithm. The actions to be carried out must be rigorously and unambiguously specified for each case. Unambiguous means it should not be duplicated, it should not be repeated. Once a step is defined, again we should not redefine the same thing, and we need to clearly specify what we are going to do in this particular definiteness property. The next one is input. A algorithm may have 0 or more inputs, that is quantities which are given to it initially before the algorithm begins. There may be 0 or more inputs for an algorithm. And output. An algorithm has one or more outputs, that is quantities which have a specific relation to inputs. Yeah, the next property is effectiveness. An algorithm is also generally expected to be an effective one. This means that all the operations to be performed in the algorithm must be sufficiently basic. They should not be complex. They must be basic. All the instructions must be basic. If there is a complex one, try to reduce the complexity in the algorithm. That can in principle be done exactly and in a finite length of time. We need to even specify the length of the time. That is algorithm development approach. Is the development of an algorithm is a plan. Actually, you are going to execute a plan in an algorithm. What is the first step, what is the last step, and so on is a step in solving a problem. Once you have an algorithm, you can translate it into any computer program or a programming language. You need to have the plan first. Our algorithm development process consists of 5 major steps. Let us see the step 1. Obtain a description of the problem. What you want to do in this algorithm. You need to have the description. Let us say you are going to perform addition of two numbers. You need to have the description like you are going to perform addition on those two numbers. Next, analyze the problem. You need to analyze, for example, in addition of two numbers, whether the number is related to integers or there are decimal parts in the number. What is the size of the numbers that you are going to perform. Next, develop a high-level algorithm. Now here you are going to write the algorithm in this step. Next step, you are going to refine the algorithm by adding more detail. For example, if you are having a formula which is having, for example, area of a square, you are having side into side, you can write 2 into side. If a huge formula is there, you try to reduce the size of the formula, or if an algorithm is huge in nature, you are going to try to reduce the size of the algorithm or reduce the number of steps in the algorithm. Is called as a refinement process. Next step, review the algorithm. You are going to cross check whether as per the intention which you have written the algorithm is meeting or not. Means for the given input, whether you are getting the exact output or there is any issue in it. Here you are having symbols. A flowchart is a pictorial representation of a given problem. It is also step by step, but we will be having pictures or symbols. In this case, if you see here, the first one is oval. It denotes the starting or ending of the problem. Next one, you are having a flow line. Yes, it represents the flow. It may be in any one of the 4 directions. It may be from top to bottom or bottom to top, side, and so on. The next one is parallelogram. You are going to represent this symbol for performing input operations or output operations. The next one is processing. Here you are going to write all the processing steps. For example, you want to perform addition, c is equal to a plus b, and you want to perform I plus plus, etc. All these operations are performed in the rectangle symbol. Now if you are having a if condition where you are having two outcomes, that is a plus, that is true or false, then you are going to use a diamond symbol. Let us start with an example of an algorithm. Display hello world. For every algorithm, the step 1 will be start. Then step 2, we want to display hello world. I am placing what I want to display in double quotes. Hello world. Then you can write here display, or you can write here print. You can write here write your wish. So I'm writing here print. Then that's it, we have printed the output, that is hello world. So I'm going to write step 3 as stop. Every algorithm will be having the last step as stop. For start and stop, I'm going to keep it full stop. So this is the algorithm for displaying hello world. Printing 1, 2, 5. So we don't have input again. So I'm going to write output is there. 1, 2, 5. Let us write the step 1. Step 1 is always start. Then step 2 is we need to print 1 to 5. Let us see one example. Write display or print. I'm going to write print 1. Then I'm going to copy this. Then I'm going to print because I want to print 1 to 5. So that is first one is print 1, then print 2, then print 3, then print 4, then print 5. Here also we are going to change the steps 1, step 2, step 3, step 4, step 5, step 6. So we are printing here all the 1 to 5 values. Then I'm going to write here step 7 to be stop. This is one simple approach to print 1 to 5. Now let us change the problem here, algorithm here. Let us keep first of all n is equal to 1. Then I am printing n value instead of 1, 2, 3. I am printing n value. Now whenever I print n is having value 1, so 1 will be printed. Then I am going to write n is equal to n plus 1. N is equal to n plus 1. N plus 1 means n becomes 2 here. Then I am going to print n. So now 2 is printed here. Then again I am going to write here n is equal to n plus 1. So n becomes 3 now. First n value is 1, here n value is 2, here n value is 3, here n value will be 4, and here n value will be 5. So that's it, print guys. So we need to stop here. So let us change the steps also. Step 1, 2, 3, 4, 5, 6, then 7, then 8, then 9, then step 10, and finally step 11, stop. So what we are doing here, we want to print 1 to 5. The output is 1 to 5. The first one step is start. Then the next step is n is equal to 1. N is the memory location which is having value 1 initially. N is equal to 1. When I am printing n, I will be getting the result as 1 because n is having value 1. So I will be getting the result as 1. What we are doing, n is equal to n plus 1. Perform addition, that is add n to 1 and store that back into n. Yes, what is the value of n? N is 1. So what we are going to do, we are going to add n is equal to n plus 1. So n becomes 2 now. Then we are going to print the n value over here. So I will be getting the result as 2. I'll be getting the result as 2. Then n is equal to n plus 1. Now the n value is 2. We are going to add 1 to it, so n becomes 3. Then we are going to again print n value in step 7. So we are going to get the result as 3. Next, we are going to again add n is equal to n plus 1. So 3 becomes 4 now. Then we are going to print the n value in step 9. So we are going to get the result as, what is n value? N value is 4. So I am going to get the result as 4. Then I am going to again increment in step 10, n is equal to n plus 1. So here now n becomes 5. So again after that we are printing the n value. So here we are printing the n value is 5. Now 5 will be printed. Then stop. So anyhow, I am getting 1 to 5 as the result, but the program has become a bit lengthier. So we need to refine this algorithm. How to refine this algorithm? I am going to modify the algorithm again. Just have a look. I am going to modify this algorithm. Same printing 1 to 5, same output 1 to 5, start n is equal to 1, print n, very good. Then n is equal to n plus 1, very good. Here we are going to increment the value. Yes, n becomes 2 over here. Then what I'm going to do is I'm going to check a condition. If n is less than or equal to 5, n is less than or equal to 5, then go to step 3. Then go to step 3. We are forcing to move to step 3. If n value is less than or equal to 5, again we are going to go back to step 3. Again print the value, n is equal to n plus 1. Print the value, n is equal. So indirectly, these 3 lines are a part of a loop. These 3 lines are part of a loop. Loop means it repeats till n value is less than or equal to 5. Okay. Then rest of them I am going to remove. So by this way we are going to refine the algorithm, and step 12 becomes step 6 now. So what we are doing, let us check again. So the algorithm is printing 1 to 5. 1 to 5, so step 1 is start, step 2 n value is again 1. I am going to remove this output as of now, and I am going to reassign the n value to 1. N value is initially 1. Then print the n value. I am getting the result as 1. Getting the result as 1. Then after that you are writing n is equal to n plus 1. So 1 becomes 2 now. 2 is stored back in n. Then if n is less than 5, then go to step 3. What is n value? N value is 2. Go to step 3. Again the cursor comes back. Step 3 at step 3. Now it is printing n value. What is n value? 2 is printed. Then n is equal to n plus 1, n becomes now 3. Then if n is less than or equal to 5, what is n value? N value is 3. 3 is less than or equal to 5. Yes, go to step 3, print n value. Now again I am printing 4, not 4. What is n value? 3. So 3 is printed. Very good. Next, n is equal to n plus 1, n becomes now 3 plus 1 is 4. Then whether 4 is less than or equal to 5, yes, go back to step 3, print n. Now we are printing n value is 4, 4 is printed. Then n is equal to n plus 1, 4 becomes 5. 5 is less than or equal to 5, yes, equal to 5, go to step 3, print n. Now 5 value 5 is printed. Then n is equal to n plus 1, n becomes now 5 plus 1 is 6. Now if n is less than or equal to 5, 6 is less than or equal to 5, no, false. Then it simply comes out to the next statement. So it stops. Okay, guys. Next, let us print this, the same thing in reverse. It is 5 to 1. Let us copy the same algorithm. Let us see what are the modifications to be made to get the same output. That is, I want to print 5 to 1. You can pause the video here and you can try on your own. Output is 5 to 1. First step is start. Now I am saying the 5 to 1, so n value starts from 5 instead of 1. Then I am printing the n value s. Now I need to print first 5, then 4, then 3, 2, 1, stop. That's it. Every time I am reducing the value by 1. So n is equal to n minus 1. Now I am going to check, instead of less than or equal to 5, I am going to check greater than or equal to. When I need to stop? At 1. If n value becomes 0, I need to come out. So these are the modifications to be done. Our intention of writing the algorithm is to print arithmetic operations. My intention of writing this algorithm is to print arithmetic operations. For this, performing arithmetic operations, that may be addition, subtraction, multiplication, we need to provide some input. Let us say I am giving the inputs as a comma b. Yes, on this a comma b I want to perform addition, subtraction, multiplication and division. For example, say c is equal to a plus b. In mathematics you will be writing a plus b is equal to c, but here this is not the case. You will be having all the time, now this part is called as left hand side and this part is called as right hand side. All the time right hand side you will be having the equation or a constant value or an expression which will be assigned to left hand side. So what you are going to write here in C language, you are going to, or any programming language, you are going to write at the left hand side the variable in which the result has to store. That is, you are going to perform a plus b and you are going to store the result in C. So that is the correct one. So you will be performing input as c is equal to a plus b, for example, then d is equal to a minus b, then e is equal to a into b. Here we don't have x, that is into operation. Here we will be having this flower representing a multiplication operation. You don't have this x over here like in mathematics. So we are going to write here asterisk symbol. This is called as asterisk symbol, used for multiplication, a into b. Then for division you may write a is equal to, or f is equal to a by b. Now a by b is going to give you the quotient. Yes, quotient. Quotient means, for example, if you are going to divide 10 with 3, you will be getting 3 as the quotient and remainder you are going to get 1 as the remainder. Yes, g is equal to a percentage b. Percentage is going to give you the remainder. So I'll be getting outputs, that is c, d, e, f, g. So I'm going to write o, u, t, p, u, t, that is c, d, e, f and g. So this is my intention of writing the algorithm. So I'm going to write start with step 1, that is start. Then step 2, I want to read a comma b values. You can write display, you can write enter 2 values. Then you can write step 3, read. If 2 values are given, you need to provide 2 variables, a comma b. In a, the first value will be stored. In b, the second value will be stored, whatever is given. Then I am going to write step 4. Step 4 is c is equal to a plus b as intended. We are performing addition here. Then step 5, that is d is equal to a minus b. Then step 6 is all the rest of the operations. You are going to write the steps. Then you have to display c value, d value, e value and f and g. So you are going to write step 9 as display or print your wish. Once you are writing display, you need to write display only for output statements throughout the program. C comma d comma e comma f comma g. Or you can also write display addition is equal to c, subtraction is equal to d and so on. Your wish, in whatever the way you want you can write. Then write step 10 as stop. So this is the algorithm for writing or printing arithmetic operations. Input is equal to a comma b, output is c, d, e, f, g, h. First step 1 start, display enter 2 values, read a comma b. After reading a comma b, you can perform the arithmetic operations. C is equal to a plus b, d is equal to a minus b, the rest of the arithmetic operations. Then you are going to display all of them, then stop. So this is regarding arithmetic operations. Now let us see factorial. The next algorithm is factorial of a given number. For example, I am having n value. I am taking a value called as n, which is having value 5. Let us see what is the factorial. Yeah, it is represented by this. For example, 5 factorial is equal to 120. Everyone knows that is what it is happening. 5 into 4 into 3 into 2 into 1. Okay, like this you are going to calculate. Now here I am writing x as into, but this is not a valid one. I hope you recollect x. So you are going to use asterisk symbol instead of into. So this is what we are going to do. First of all, I need to have a counter which will be having value 5. Then it becomes less by 1. Then it becomes 4, then 3, then 2, then 1. If I'm going to get 0, 0 multiplied with anything is going to become 0. So I need to stop there. Okay. So let us see what is the input. I need a number. Let us say n. In this case, I'm having n value as 5. Then what is the output? Output is factorial of n. Okay, that is my output. So let us start the algorithm. Start. Step 1 is start. Then step 2, I am initializing the n value is equal to 5. So I want to find the factorial of 5. That is my intention. Then step 3, I am going to take a counter variable which starts. No, I want to take a variable called as sum. And the initial value of sum will be 1. What I am going to do is I am going to perform multiplication. 1 into any number is that number. If I am having 0 initially, anything into 0 is 0. So I am going to start the initial value as 1. Some people may take product, PROD over there. I am taking here sum. Step 4, that is n is equal to, that is sum is equal to sum asterisk n. I'm multiplying the n value with sum, that is sum value initially is 1, 1 into n, that is 1 into 5, 5. First I am storing 5 in the sum, that is our intention. First we have to multiply 5, then 4, 5 into 4 20, 20 into 3 60, 60 into 2 120, 120 into 1 120. That is the result what we are expecting. So first I got fifth value 5. Then what I need to do? I need to reduce the n value by 1. Step 5. How to reduce? N is equal to n minus 1. Then after reducing, I need to cross check whether the n value is equal to 0. Then I need to stop. So I'm going to write step 6. If n is less than, greater than or equal to 1, then go to step 4, because step 4 is sum is equal to sum into n. I am reducing the n value, multiplying, reducing, multiplying till I reach 0. Step 4, then I need to display the result, that is 7. Step 7, display. You can write factorial is equal to, you can write sum is having the factorial. Then step 8 you are going to write as stop. Okay guys, let us cross check this algorithm. First of all, I am going to write output as factorial of n. Start, initially n value is 5. Let us check. Let us remove all this stuff. Yes, let us make n value as 5 initially. Then sum is equal to 1. One more variable I require called as sum. So the name of the variable is sum. Initially sum value is 1. So I will be having initially 1. Then I am writing sum is equal to sum into n. Sum is equal to sum into n. Let us say 1 into 5. I will be having 5 in the sum for the first time. N is equal to n minus 1. Now n becomes 5 minus 1 is 4. Then 4 is less than or equal to 1, s that is greater than or equal to 1, s go to step 4, sum is equal to sum into n, 5 into 4, 20, store back in sum, so I'll be having 5 for the 20 in it. Then n is equal to n minus 1, n becomes 3 now, then go back, that is n value is 3, 3 greater than or equal to 1, s go to step 4, now step 4 is sum is equal to sum into n, 3 into 20, that is 60 I am getting. Then next step is n is equal to n minus 1, reduce the n value by 2, by 1, that is 2 greater than or equal to 1, s go to step 4, step 4 is equal to sum into n, 6 into 2, 120, store again back into sum. Then reduce the n value by 1, n is equal to n minus 1, n becomes now 1, 1 is less greater than or equal to 1, s go to step 4, sum is equal to sum into n, 120 into 1, I am getting again 120. Then n is equal to n minus 1, now n minus 1 becomes 0, 0 is greater than or equal to 1, false, it comes out. Now it displays factorial is equal to sum, it displays factorial, then some value, that is 120. It is going to print here factorial is equal to, then it prints 120. So this is the outcome of this algorithm. Next algorithm, let us print a multiplication table. What do you mean by multiplication table? I'm giving 5, then I need to get 5 into 1 is equal to 5. I hope you recollect 5 table. Then I will be getting 5 into 2. This is one example, let us see. 5 into 2 is equal to 10. I hope everyone recollects this one. Then 5 table, that is 5 3s are 15. Then I will be having so on. I'll be having so on up to 5 into 10 is equal to 50. So when we are going to stop? So this 5 represents our n value, whatever we are giving, it may be 5, 10, 8, whatever it may be. Then here I am having a counter variable which starts from 1 and ends at 10. Okay, then this is nothing but n into that counter variable I am going to get here. So let us write the algorithm. So what is the step here? The step will be something like this: n into, say, one counter variable I am using I, it is equal to n into I. I'm going to print n into I over here. Is that right? Yes. Here it is a symbol, so I'm going to write in single quotes. Asterisk is a symbol to be printed. Then equal to is also a symbol, so I'll be writing in quotes. The rest are the values to perform n is equal to n into I. Let us see the algorithm first. So the step 1 will be always start. Then step 2, one second, 2, step 2 is n is equal to 5, for example. Then step 3, I want to let us assign the value I value is equal to 1. This is a counter variable. Then step 4, when we need to stop, first of all let us print display, that is n is small case, I is also small case, n is equal to n small case I into I. This line I am going to print. Then step 5, I am going to increment I is equal to I plus 1, because every time I value must increment by 1, that is I plus 1. Then step 6, I am going to check if I value is less than or equal to 10, then go to step 4, because step 4 is displaying. Step 6, that's it guys, stop. So what is happening here? It is printing the value and increment the I value. Okay, it is going to repeat for 10 times. Multiplication table of n. Let's go to the next algorithm. So we want to print the Fibonacci series of a given number, say up to a given number. Given n, let us say. Fibonacci series in the sense, first I will be having value 0, then the 1, then 0 plus 1, 1, then I am going to add the last two values 1 and 1. 1 plus 1 I will be getting 2, then I will be adding the last two values, that is 1 plus 2 I will be getting 3, then 2 plus 3 I will be getting 5, 5 plus 3 I will be getting 8, and so on till a given number. Okay, we are going to add the previous two values, 0 plus 1, 1, 1 plus 1, 2, 2 plus 3, 5, 3 plus 5, 8, so on. Okay, this is Fibonacci series. Let us write the algorithm for this one. So output is Fibonacci series, that is 0, 1, then 1, then 2, then 3, then 5, like this. I'm going to keep it every time. So next one, we are going to write the start. Step 1 is start. Step 2 is we need to have maximum value display. Maximum value, then step 3 read into cyan. Step 4, now here we'll be having initially one variable will be there called as f0, f1, f2. I'm taking three variables. Okay, f0, the initial value is 0 because it starts from 0. Then step 5, the second value f1, which is equal to 1. Then I am printing these two values first. Step 6, display f0, f1. So I got the output as, the first output is 0, then the next output is 1. Now I'm having two variables as of now. One is called as f0, next one is called as f1. Okay, so this one is f1. I will be taking one more variable called as f2. So initially f0 value is 0, f1 value is 1. We haven't decided what is f2. Say n value is say 12 is the, or 13 is the maximum one. Okay, let us say n is maximum one, that is read n. f0 is 1, 0, f1 is 1. Now display f0 comma f1, so 0 and 1 are printed. Then I'm going to write step 7, that is f2 is equal to f0 plus f1. Then step 8, we are going to display the f2. Next, I am going to swap the values. Step 9, that is f0 is equal to f1. Step 10, that is f1 is equal to f2. So what is f2? f2 is equal to f0 plus f1. So f2 is 0 plus 1, I'll be getting 1. Okay, then display f2, f2 value is 1, so 1 is printed. Very good, so forth. Then what I'm doing, f0 is equal to f1. Why? Because we have to add all the time the adjacent values, the previous values which are printed. So I'll be moving f0 is equal to f1. So 1 will be moved to f0. Then f1 is equal to f2. Then f1 is equal to f2. So I'll be again moving 1 to 1. Then step 11, I'm going to cross check whether I'm going to perform another step. Step 11, f2 is equal to f0 plus f1. Now I'm calculating f2, 1 plus 1, I'm getting 2. So I'm checking now whether my f2 is equal to given value or not. F2, if f2 is less than or equal to n, then go to step where we are displaying. In step 8 we are displaying. Okay, go to step 8. What is step 8? Display f2. Now I am displaying f2 value. F2 value is equal to 2. So 2 will be printed now. Then I must make f0 as 1, then f1 as 2. The same thing is going to happen after displaying. We are swapping the values. Now f0 becomes 1, f1 becomes 2, swapping. f0 is equal to f1, f1 is equal to f2, then f2 is equal to f0 plus f1, 2, 1 plus 2, I'll be getting 3. Then I'm checking whether 3 is less than or equal to 13. Yes, 3 is less than or equal to 13. Then go to step 8, print the f2 value. f2 value 3 is printed now. After 3 is printed, again f0 is equal to f1, assign whatever is there in f1 to f0, then f1 is equal to f2, f1 is equal to f2, print the 3 value here, 3, then f2 is equal to f0 plus f1, 2 plus 3, I'll be getting 5. Then if 5 is less than or equal to n, s, go to step 8, display f2 value. Now after 3 we'll be printing 5. Then f0 is equal to f1, move the 3 to 2, 3 is moved here. Then f1 is equal to f2, move the 5 to f1, 5. Then f2 is equal to f0 plus f1, that is 3 plus 5, we are going to get 8. 8 is less than or equal to 13. So go to step 8, display the f2 value. So f2 value is 8. I am going to print the 8 over here. Then again moving that content of f1 to f0, whatever is there in f1 move to f0. Then move the content of f2 to f1, f2 is having 8, move it to f1, 8, then f2 is equal to f0 plus f1, so 5 plus 8 you are going to get 13. Then you are going to check whether 13 is less than or equal to 13, s, go to step 8, again display the 13 value. Then f0 is equal to f1, move the f1 value to f0, that is 8, then move the f2 to f1, that is 13, 13 plus 8, you are going to get 21. Then you are going to check whether 21 is less than or equal to 13, no, false, then step 13 will be stop. Step 13 is stop. So we got the intended output 0, 1, 1, 2, 3, 5, 8 and 13. We stop here. That's it guys. In today's video we are going to stop here. In the next video we are going to study the flow charts.